Okay, so in this assignment we're looking at a series of heating curves, and what you've got to remember about heating curves is basically they always look like this. The bottom axis is going to either be heat energy or time as heat energy is added, and the y-axis is always going to be temperature. And so what we find is that you always get a similar looking curve. It's sloped, and then it's flat, and then it goes up, and it's flat, and it goes up. Now, basically, the three sloped areas represent the coldest one is going to be where it is solid, the middle one is where it's a liquid, and the upper one is where it's a gas. So on the in-between areas then, here is transitioning from a solid to a liquid, in other words, it is melting. Here is transitioning from a liquid to a gas, in other words, it's boiling. So if we look here, it says, what is the melting point of substance A? Well, here's substance A. Melting is going from a solid to a liquid. And the temperature where that occurs is right here. So it looks like it is 150 degrees Celsius. Now, at what temperature does substance B melt? Well, okay, so we're going to look here. I'm going to say this first slope here is where it is a solid. The second slope here is where it is a liquid, and the third slope here is where it is a gas. So melting involves a change from solid to liquid. That happens here at 300 degrees Celsius. So now boiling point is the same deal, except the difference with boiling point for number 2. The boiling point happens when a liquid transitions into a gas. So the temperature that happens with substance A is right here. Here is where it's changing from a liquid to a gas, and it's happening at 300 degrees Celsius is the boiling point of substance A. And the temperature that happens for substance B is right here. Here it's a liquid, here it's a gas. This is the temperature the change occurs, and it looks like that's 450 degrees Celsius. Alright, now let's go on to 3. It says, how much heat energy was needed to turn sample A from a solid at the melting point to a liquid at the melting point. So here's how we do this. We say, okay, we want to know how many calories of energy did it take to turn sample A from a solid at the melting point to a liquid at the melting point. So what is the energy difference between here and here? So I come down here, that is 50 and that is 100. So the difference between here and here, this difference in between here, is 50 calories. So let me go ahead and write that in. The answer there is going to be 50 calories. Now let's look at the next question. Number 4, how much energy did it take to turn sample B from a liquid at the boiling point to a gas at the boiling point? So let's take a look up here. So now we have, here it is a liquid at the boiling point. So let's just see where that started. That started right here at 250. So I'm going to put a little mark here at 250. And then we want to know how much energy to turn it into a gas at the melting point. So that would be here at 375. So the difference between 250 and 375 is 125. So from here to here, that's basically the width of that plateau, is 125 calories. 25 calories. So what is the heat of fusion of sample A? So the heat of fusion is the energy needed to melt 1 gram of the sample. So we look here. So to take 1 gram of sample A from a solid at the melting point to a liquid at the melting point. So what we have to do now, so we know that it's 50. It took 50 calories to melt this sample. The question is, how many grams of sample did we have? Well, let's go take a look. What we had here was, let's see, it says we had 120 grams. Alright, so what we need to do then is we need to come back down here and say, well, it took 50 calories to melt 120 grams, so therefore the heat of fusion for this substance is well, let's just make it 0.42 calories per gram. So it takes 0.42 calories to melt of energy to melt each gram. And now number 6 is, what is the heat of vaporization? So it's a very similar concept, but here we're doing it with at the boiling point. Let me just move it up here a little bit. So if we look, basically the heat of vaporization is the energy needed to turn 1 gram of a sample from a liquid at the boiling point to a gas at the boiling point, and we found it to be 125 calories for that sample. So for number 6, we're going to say 125 calories was needed to boil that sample. We have to divide by the mass of that sample to find out how many calories per gram. So let's see how big our sample was. And I see here our sample was 85 grams. So therefore I need to come back down here and I need to say I'm going to divide that by 85 grams. And what that gives me in this case is 1.5 calories. That's a terrible cal. Per gram. It took 1.5 calories to boil each gram of that substance. Well, now let's go to the back side and see, oh look, he got the numbering wrong. At least we know Mr. Sampson was not abducted by aliens and replaced with one of them. Alright, so it's just like the first side. It's the exact same thing. So let's see how we do. We want to find the melting point of substance C. Here's substance C. The melting point, well, let's just go ahead and label solid, liquid, gas, solid, liquid, gas. Okay, so in this case the melting point is the transition from solid to liquid. Here it happened at, it looks like, negative 100 degrees. I'm not going to write the degrees Celsius because it's hard to write with this darn thing. And we're going to do it for substance D. For substance D, here it's a solid, here it's a liquid, here's where the transition took place. It took place at a temperature of 400 degrees Celsius. And then we say, what is the boiling point? Well, what is the boiling point of substance C? Well, that's where it changes from a liquid to a gas. It happened here at, it looks to me like 50 degrees Celsius. And then the same thing is going to be true over here. Here we have a liquid transitioning to a gas, and that temperature was 450 degrees. Alright, we're doing great here. Let's just roll this on up. And let's see what we got here. Alright, number 3 is going to say, how much heat energy do it take to turn sample C from a solid at the melting point to a liquid at the melting point? So we want to know how much energy did it take to turn this sample C from a solid at the melting point to a liquid at the melting point. So what we're really saying is, how many calories wide is this plateau? So let's just say, so in other words, from here to here, I need to know how many calories that is. So how many calories across is this gap? Well, let's just see. Here's 200, here's 100, so that's 100. It looks like that's 100. 150 is what it looks like to me. So it was 150 calories. And let's keep moving on up here. And then number 4, how much heat energy was needed to turn sample D from a liquid at the boiling point to a gas at the boiling point? So we're doing the same thing except with the upper plateau. So we're going to come up here and we're saying how much energy did it take to get from here to here. In other words, how wide is this plateau? Here the liquid started boiling, here it finished boiling. How many calories of energy did it take to accomplish that task? Well, let's see, we're going to come down here, and that's 125 calories is when it started, and it finished here at 275. So it went from 125 to 275. Help me out here. I think that's 150 calories, isn't it? Okay, so let's go up here and say, gosh, that was also 150 calories. I should write more interesting worksheets. So now to find the heat of fusion, you simply divide the amount of energy it took to melt the sample by the mass of the sample. So I'm going to say 150 calories of energy was required to melt the sample, and the size of the sample was, was right here. It was 24 grams. So I'm going to divide 150 by 24 grams. So I'm going to say divided by 24 grams. And that's going to give me, I think it's 6.25 calories per gram would be the heat of fusion for that specimen. And then let's go ahead and try to find the heat of vaporization then for D. So again, if I look at D, D had 150 calories. So let's go ahead and write that down, 150 calories. And I simply have to divide it by whatever the mass of sample D was. So let's go up here and see sample D had, it was big, 344 grams. I have to divide that by 344 grams, which gives us a very wimpy heat of vaporization of only 0.44 calories per gram. Well, I hope you enjoyed that as much as I did.